Hello, everyone. Oh, it's still counting. Hi, everyone. I'm Csaba Tóth from GDG Fresno, and I'm representing 10 or even more GDGs from the Pacific region and other North America GDGs. You can see it on the screen. You can see it on the screen? Yeah, okay. And this is an I/O Extended web edition. We united several GDGs. I/O Extended is an event where we follow up the big Google I/O conference and we reflect on it. This web edition focuses on web development topics, and we will have 3 presenters the following 3 hours. First presenter will be Dominika Zając, and she's a Google developer expert for web, and she's a software engineer at Qualtrics. She's gonna talk about how to use Google Chrome DevTools to improve accessibility of your web page. And then we will switch over to another YouTube stream, which URL is almost the same as the previous URL, it just ends with 2. And Joel Paredes will talk about Google Maps data-driven styling. And our final talk will be by James Daniels, who is a Googler. He works as a software engineer at Firebase, which is a subdivision of Google. And he will talk about building modern web apps using Firebase. So these 3 talks will start soon after one another. The last talk, the 3rd talk, will also have its own stream. The link you can see on the screen towards the top, it ends with number 3. So we will give you enough time to switch over between these streams. And the talks are broadcasted to YouTube, to Twitter, and also LinkedIn. And they are recorded automatically. They will be available at the North America GDG YouTube channel. And so you can, if you miss any of the talks, you can watch them back, replay them as you wish. And this is also kind of a privacy notice that the talk is recorded. And so the way you are interacting with us is through the YouTube chat. We will watch the YouTube chat and we'll try to relay questions to our speakers. So feel free to ask any questions, although possibly we will answer them at the end of the talk. And yeah, with that said, the time is 2:05. Here, the local time is 2 p.m., 5 minutes past 2 p.m. And wherever you are in the world, good morning, good afternoon, good evening, good night for you. Thanks for joining us. And I think let's go ahead and give the stage. Sorry, let's go ahead and give the stage to Dominika Zając. And I'm very excited of her talk.
Hello, thank you very much for inviting me. Thank you, organizers, for doing this event. Yeah, and I believe we can go with accessibility because it's the topic of my presentation today. If you are here, you've probably seen this page as it's the page of our today's event. But did you know that according to Colorblind Awareness Association, 1 of 12 men and 1 in 200 women in the world see them differently because of color blindness? For some of them, our well-known page may look like this. But what's maybe even more surprising for some of you, Seeing the world in grayscale is not the only way how colorblind people are seeing web pages. For majority of them, our web page will look like this, this, or this. Today, I want to show you some tips on how to use Chrome DevTools to improve accessibility on your web page. But before we will go there, let me shortly introduce myself. As it was said, I'm Dominika Zając and I am from Poland. I am programmer from education, profession, and passion, and currently I work as a software engineer at Qualtrics. Apart from that, I'm conducting different workshops and lectures, especially for kids and people who are just starting their career with web development. And I'm also a huge fan of karaoke, so if you want to talk about any of those topics, feel free to reach out to me via my blog, LinkedIn, or Twitter. Now, let's go to the accessibility. And what is accessibility, you may ask? Simply speaking, accessibility in IT is building our solutions in a way that are available for everyone, including people who have some vision, motion, or cognitive deficiencies. We have to remember that some people struggle using the internet the same way as majority of ours. They are using some screen readers, special keyboards, but accessibility is also for people who just need bigger fonts on their pages, broke their arm and have to use the typical keyboard a little differently for some time, or for people who are just in a really loud place and can't hear everything. You may also have seen this shorter version of accessibility, A11Y. It's created from taking the first letter, A, the last, Y, and counting number of letters between them. Okay. There are many, many reasons for taking care of accessibility in your software. First of them, the most obvious, is providing equal access to information for everyone. Also, building readable and usable web pages make them easier to navigate and understand for everyone, not only people with disabilities, but for everyone. What is also important, the accessible pages are better positioned in search engines. And what is more and more important, accessibility may be required by your local law. And if you're here, you probably know that, but for those who don't know, what is Chrome DevTools? It's just developer toolkit for building web applications already built in your Chrome browser. You don't have to install anything, it's just available for free. And how to open it, some shortcuts on the screen, and there's also a way of just clicking in top right corner of your browser, choosing More Tools and Developer Tools to open this new tab, where you have many, many tabs like Elements, where you can preview DOM structure of your web page, where you can see requests on your web page in Network tab, and so on. But today we will focus on accessibility. And first of the things I want to propose to you is a small experiment. In the beginning of my presentation, I showed you a preview how the same web page may look like for people with different types of color blindness. And you can do exactly the same experiment just from your couch. Opening Chrome DevTools, finding three tabs in the right corner of Chrome DevTools tab, then choosing More Tools and Rendering. One of the sections visible there is emulating vision deficiencies, where you can choose blurred vision or one of different types of color blindness. Where you choose them, you can just emulate different color deficiencies on any page you are visiting. Check if everything is visible. Can you read everything on your web page? Are all information still understandable? And if maybe something which depends on the color. Some live case example, why we shouldn't rely only on color when communicating something. This is the agenda I received some time ago with words. The minimal time is in green and the maximum is red. I'm not colorblind person, but someone just ran out of color toner in their printer, and I also had a problem with understanding this agenda. So, tip for you, do not just rely on color when communicate something. The next thing, what I want to show you are some ways to detect problems with accessibility. Because this experiment from the previous slide is nice to have, but we need some ways to check accessibility when we are building our web pages. So let's take a look at the example. We have our web page and we will open Chrome DevTools just to take a deeper look on that. We will go to Elements tab and click this chooser to focus on our link. When I hover over this element, I see this tooltip with short version of styling applied on this element. And here I have also accessibility section. These green icons close to contrast and keyboard focusable are saying me it's okay. And I can also preview here name, role, and is this event keyboard focusable. The other thing we can do is focus this element and goes into Styles tab. When we go into the color and click on color picker, you may notice contrast ratio section here. And if I change my color to something not really visible for the user, or maybe something else, you may see that the icon now is red. It's telling me that something is wrong with color contrast ratio of this element. When I extend this section, I can even check it against two standards. And when I click on that, I will receive a link to the blog when I can read more and understand why it's so important and how I can fix it. Okay. Checking one element at a time may be nice when we are focusing on only small elements, but very often we need a fast way to check everything on our web page. And here we have also a way to check color contrast ratio on all elements on our web page. We can use another tab for that called CSS Overview. It's hidden in More Tools option. When I go there and capture Overview, I'm receiving the summary of all CSS used on my web page. And here I have a section called Contrast Issues. As you may see, I have 7 contrast issues on my web page. And when I click on that, I will receive also list of all elements which are failing. And they are also focused on the UI, so I can check what exactly is wrong. When I want to check something more, not only color contrast, but also other problems on my page, I can use Lighthouse Audit for that. It's in Lighthouse tab, where I can choose in categories accessibility and analyze my page. After a few seconds, I will receive a whole report telling me what is good and what is bad on my web page according best practices in the accessibility. The overall score is counting between 1 and 100, where score below than 50 is bad, 51, 89 is medium, and higher than 90 is good. What is nice, we have also sections here telling us which test failed and what we can improve here. Also, past audits, what is not applicable, and what is also super important, things that cannot be checked manually, telling us what step by step we should check to be sure that our web page is accessible. And before we will go to the next slide, I have a small question for you. Hope you will answer me via chat. What do you think? Will robots take over the world? I'm waiting for your answers. Hope you will help me with this question. Okay, everyone is shy, so I will answer this question. In my opinion, they will not. And there are two reasons for that. First of that, they are not really smart yet. And sometimes they are a little dramatic, like the robot from the tweet visible on the screen. The second, more important part in our presentation is that 57% problems with accessibility cannot be detected via automated tools. It's why we have to still remember about our manual audits, and we can use this list of elements to check from Lighthouse to know what to check. And if you are using code review in your team, it's nice to add a checkbox to your checklist to check accessibility during each change in your code. Okay, we were talking about how to detect problems with accessibility. Let's talk about how to fix and improve them. And for that, let's start with insufficient color contrast ratio, because it is the one of the most popular problems with accessibility in our web pages. Let's go back to our CSS page. CSS overview. Okay, as I said, when we go to the element, we will receive list of failing elements here. And we can click on them just to show them on the UI, but we can also navigate to elements to know not only visually where we have some problems, but also in our code. When we go from here to the style section and click on this drop-down color picker, we can use a button visible just close to the score in a given category, and Chrome DevTools will propose to us a new color as similar to the previous as possible, but fulfilling the color contrast criteria. Of course, it will be changed only here and will disappear after reloading the page, but we can just take this color and change it in our source code, which is super useful and which is easy way to fix the problem with color contrast ratio. The next very popular problem with accessibility on our web pages are problems with animations. And now it's a warning that if you are sensitive for problems with animation, I have some animation on the next slide, so please be aware of that. And yeah, it's how we were building web pages some time ago. Oh, I see my GIF that didn't start. Don't worry, you may see a lot of colors, a lot of GIFs, a lot of happening on the web page. And many people may have problem with focusing on that. Many people may have problem with understanding what's happening here. And they need some way to stop those animations. And there are some rules with animation. Each animation may have option to pause, stop, and hide it. What is nice, we can reduce animations even from our operating system level. And it's how it looks like, for example, on a Mac. So we are going into accessibility, and in display tab, we have an option to reduce motion. As a web developers, we can read it and we should support it using media query, prefers reduced motion, or in JavaScript using this code snippet. Chrome DevTools may help us emulating this property to build and check our code. And again, we are going to the rendering section we saw previously, and here we can just emulate this feature, thanks to which we can just check and develop our code quickly. Okay, and the next thing, fixes after Lighthouse audit. Maybe let's go back to our audit we did on the web page. And as I said, we are receiving this overall score, which is really nice on this web page. But we have also things we can improve, like insufficient color contrast ratio, or lists do not contain only Li elements. What is nice in this report, for each failing item, we are receiving some description and link to the blog where we can learn more about it and understand what should be improved and how. What is also nice, we have a list of failing elements, and again, we can just go to the Elements tab and fix it as needed. As I said previously, we have also here option to see which test passed audits. And when you are just starting your journey with accessibility, it's a good practice to just check what was taken into account and what you should remember for the next time. Here, the same story is with things that are not applicable on this web page, but probably will be useful for you in the future. Those reports can be downloaded, sent to someone else, so you can work and improve it quite easily. And there is one more thing I want to show you. It's using accessibility tree to debug. And I changed a little our web page. As you may see, I changed this first image and it has no accessible name on it. We can see it in hover in accessibility section, name is empty, when on other images, it's okay. Let's say I want to learn more about it. I can go into tab called Accessibility, enable full page accessibility tree, and reload DevTools to see changes. As you may see, I have new icon here. When I click it, I will see how our web page look like for screen readers. So it's accessible tree, which is simpler than our code in HTML. It's different than our DOM structure. It has all elements visible to the screen reader, but has no divs or spans and things like that. What is nice, we can navigate back and forth between DOM structure and this accessibility tree. And when we, for example, want to focus on my image, we can see it's here. So it's here. In accessibility tab, I see it has no ARIA labels, alt is empty, and so on, so on, so on. When I have it focused, I can go to the DOM and see how it looks like in the code. Let's say I will play a little with that because I'm debugging and checking something. So when I edit it as HTML and, for example, add aria hidden true, which is a way to say that a given element is not visible to the screen reader and should be ignored. When I go back to this accessible tree, I see this image is ignored. And I am also seeing this aria attribute, aria hidden here. What I should do here, it's not hiding it. So I should remove this aria hidden or change it to false. But I should add some aria label. Thanks to that, even users using screen readers will know what is on the picture, and they will know what's happening there. Also, this accessible tree may be super useful when you are trying to understand what is happening when the user is using a screen reader and something is not read or read in wrong order, or something else is wrong is happening there. So I strongly recommend you using this accessible tree to debug and improve and fix all mistakes, all issues you may find connected with accessibility. Okay, I will also show you how it looks like. So going back to my slides. Yeah, this one icon is switching between DOM view and our accessibility tree view. And in the end of my presentation, I have a small appeal for you. Let's make the internet accessible for everyone. And let's remember that these changes for accessibility improves like not only for people with disabilities, but for everyone who is using your web page, for all users. If you want to learn more about accessibility, you can use one of the links visible on the screen, Twitter, Google Access. You can go to the webpage google.com/accessibility. You can also learn more from the blog about web fundamentals. And thank you very much. If you want to stay in touch, let me know. And if you have any questions, I will be happy to answer them. Okay, I'm not seeing any questions yet, but I hope something will show up. If there are no questions, I can go back to the slide with materials you can use to learn more. I believe you may take a picture of that or some screenshot, and you can learn more about accessibility. Hope you found this presentation useful, and I hope you learned something from there, because accessibility is a really interesting topic, but quite new for many of us. Thank you, Sherry, for listening to my presentation. Sherry just wrote that didn't know that the Chrome DevTools are supporting some accessibility features. Yeah, it was a surprise for me some time ago too, when I learned about them. But even if they are looking very small, those changes, those tips I showed you, make a web developer work much easier and much better. So hope they will help you too. Okay, I see that we have our
Thank you so much, Dominika, for the presentation. I learned some tricks which I will try to use in the future. It's really good to, yeah, I think color blindness affects more than 10% of the, or about 10% of the people. So it's actually...
Yeah, it's a lot, and very often we are not aware about that because it's not just seeing the world in this grayscale, it's just seeing colors a little different, but it may be super problematic. So yeah, we have to remember about it while developing, while designing.
Maybe I will wait just a few more moments because I don't want to break the session with the raffle form. So we have a Google form where you can evaluate each of the sessions, and also it serves as a raffle entry. So we can gather your contact information, including mailing address and your name, email, so we can contact you back if there's something. And so please give us feedback, although this is not an anonymous form because I need to gather your contact for the raffle. But don't hold yourself back. If you have any constructive criticism, we are very happy to hear about it. And we will share it with our presenters. So, but those evaluation sections are optional. Actually, even the raffle section is optional, but the form requires login. So we can track you, because in the end, at the very end, after the third session, we will perform the raffle. You don't have to be present for the raffle. So if you need to go because it's Friday, that's fine. So then we can contact you back in email that you won. And yeah. So let me know if for whatever reason this link wouldn't work. I think I tried it in a private window. But then I will adjust if there's something wrong with it. I'm looking to the side because I'm running the YouTube stream, so you can. Yes, Sherry, I forgot to add that the form, you will receive an email once you submit it, and you can keep editing the form if you would like to. So although there's all the free sessions there, just ignore the session 2 and session 3 right now. Or, as I mentioned, it's optional. You don't necessarily have to fill out the first session evaluation. But yes, theoretically, I set up the form in a way that you should be able to go back and edit your response. You should be able to receive your response, an email, and I think that provides a link for you, or maybe even if you visit it with the original link again, I think you can edit. Don't worry about it. If you can't edit, just submit another one. That's all right as well, because I will be able to, I think, deduplicate if you have multiple submissions. All right, thanks, Sebastian. Thanks that the link works. And so we are 35 minutes in. It's 2:36 p.m. So we are a little bit ahead of schedule. Maybe I will pull up a little slide deck for this occasion. And since this is I/O extended, let me set up my screen share. Just a second. Just a second. I'm gonna setting up the share. I think I'm gonna share my entire screen. I will be brave and share my entire screen. No, I'm sorry, that's not gonna work. Just give me a second, because yeah, I don't. A second, because this I'm looking at the presentation here. Just a second. In the meantime, you are just go on and fill out the survey while I am fiddling with this. The presentation. And while I am searching, while I'm setting this up, I would like to also tell that there will be other big events coming up. For example, in the fall, we will have the DevFest season. DevFests are bigger events than this event. So usually not just 3 sessions, but sometimes even more, a whole day of conference, sometimes 2. So where you signed up for this event at the gdg.community.dev, you can see other GDGs as well. Keep an eye out for DevFests. Many GDGs will organize their DevFests. So that's something you keep an eye out on. So the slide deck will be about state of responsiveness. And let me, I have a little, let me copy it to right place here. Sorry about these technical issues. And I will kick it in after this is done. Okay, so just give me 1 more minute, because in this, our presentation software, I'm trying to respond Hey, so now I think you can see my screen. Finally, I set up the slide deck. And, so this is a short slide deck about the state of responsiveness on the web. And so what is responsiveness? Well, simply stated, it means understanding how quickly web pages respond to user input. For example, when you try to open the menu on a website, how long does it take before it appears to be doing something at all? Or perhaps I click a button to add an item to my cart on a shopping website. How long after I interact before I can actually see that my item is being added? Let me tell you about a recent encounter I had with responsiveness. It's actually not related to the web at all. You see, my car has a cruise control feature, which I can use to maintain vehicle speed automatically. Before I can use the system, I have to press the button to turn the system on. Nice and simple. Nice and simple, except last year, I upgraded to a new vehicle, and this one has adaptive cruise control. Now my car uses a myriad of sensors, 360-degree cameras, artificial intelligence, and even math to help me drive. It's actually pretty amazing. Of course, all of those smarts come at a cost. Now, when I try to turn the system on, it takes several seconds to engage. Perplexingly, pressing that cruise control button appears to do nothing before finally engaging. This is incredibly frustrating. It doesn't surprise me that it takes a few seconds to start, but why don't I get any feedback during that whole time? Sometimes I will press the button and wait, unless I accidentally didn't press the button quite right, so I'm waiting around for nothing. So I press the button again, except actually I did press the button right the first time. I just didn't want to wait long enough, and now I've turned it back off. And now I'm sort of rage clicking, if you know that phrase. Now, in a perfect world, the system would just always turn on instantly. But we know that can't always be possible. Instead of fully waiting for everything to finish, it should really just respond to my input with feedback, even if it takes a few more moments to fully complete. And that's what we mean by responsiveness. User interfaces should give some useful initial response to every interaction quickly, even when they cannot complete everything instantly. On the web, that means that the time from each interaction to the next paint should be reasonable, and that the feedback should be useful. As you can see, it's pretty clear that poor responsiveness affects me personally. But how do we address such problems at scale? Well, first, let's look at what we have already learned from Core Web Vitals metrics. We've worked to give sites a clear and simple way to measure page loads and provided tooling to help them improve. With clear guidance came big improvements. Web developers worked diligently and have now saved us all at least 1,000 years of waiting around while loading. And what was in Q4 alone? And that was in Q4 alone. Instant loading makes browsing a joy, but it's really just a part of the web performance story. Actually, 90% of the time users spend on the websites is after the page has loaded. And it's probably not surprising that users really tend to interact with sites after loading is complete. That's why we've been working on better measurement for responsiveness beyond load. And when we start measuring, we found out that it definitely needs improvement. We found that over 70% of users experience terrible responsiveness at least once a week. And that was when we looked for 1 whole second of interaction latency with no visual feedback whatsoever. So it's 70%. Yet we know from user experience, research from user experience research that 100 milliseconds is the guideline for latency to user input. This has been our responsiveness target in Rail model for years. Finally, we found that users appreciate good responsiveness a lot. We see that when a user typically experiences good responsiveness, they will regularly load twice as many pages as those of us who are regularly frustrated by high interaction latencies. All right, so we know it's important, but how do we measure responsiveness today? Well, first, input delay is the current core Web Vital for measuring loading responsiveness. FID is actually the oldest metric of the core Web Vitals, already having widespread adoption 4 years ago. FID should still be your first step to address responsiveness. And have you ever, FID now has 95% pass rate. What an incredible success. Developers like you have worked to reduce first input delays. From simple things like this widespread adoption of mobile viewports to incredibly complex changes like the fact that popular web frameworks started bootstrapping JavaScript using task schedulers, and they make sure to promptly yield to the main thread whenever there is an input pending. I mean, incredible work. Good job. FID is no longer the problem it once was. But the pass rates have not always been that high. We have seen a 13.4% improvement over 4 years. Put it another way, users are now over 3.5 times less likely to visit a site with high first input delay. Okay, that's good news. Unfortunately, FID has fairly large blind spots. Really, we know that web isn't actually 95% great at responsiveness. I mean, in your own experience, how often is it that first interaction the only one that matters to you? That's why we, the Chrome team, are launching a new experimental responsiveness metric. It's called Interaction to Next Paint. INP is a full page lifecycle metric, just like the cumulative layout shift. That means it measures all interactions, not just the first. This is called runtime responsiveness to help differentiate from just loading responsiveness. INP measures the whole input latency from when the user interacts until they actually see the visual response, not just the initial delay on main thread. INP measures all the important discrete interactions, including tap, drag, and keyboard, and ignores continuous events like hover or scroll. Now, because this is new and this metric is new and the Chrome team is still working with all of us to evaluate it thoroughly, they are labeling it as an experimental metric for the time being. And the Chrome team's signaling that they hope to see it evolve to replace first input delay as a core Web Vital eventually. INP has already been as an experimental responsiveness metric to the Chrome User Experience Report, or CRUX, in March, meaning you can already check your site's responsiveness data going back to the start of Q1 2022. This CRUX data has helped find sites where FID was fine, but the new INP score was poor. In most cases, when we take a look, it's been easy to uncover real responsiveness issues quickly. As one example, we found that some third-party bot detection libraries were waiting until the first interaction and then executing a bunch of heavy script. This didn't add input delay or even long task during load, but it certainly delayed user responsiveness heavily. The issue remained completely hidden from field metrics like FID and lab metrics like total blocking time, but was easily caught with the INP. Now, if CRUX data is not enough, you can take things into your own hands and measure INP in the field using the Web Vitals JS library. Doing so allows you to report extra insights that Crocs cannot provide. For example, which interactions with which elements around which times are actually leading to responsiveness issues. Precisely identifying the source of the problem is often half the battle. You can also just measure IMP in your local browsing by adding it to the Web Vitals Chrome extension. Finally, the Chrome team is working to improve support for responsiveness in lab tooling. After all, the whole point of knowing when your site isn't meeting responsiveness targets is to quickly work to address them. Coming shortly, you will see IMP field results in page speed insights, and we are exploring ways to add IMP to the Chrome Developer Tools Performance Panel and Lighthouse. Even better, instead of requiring manual testing for responsiveness in the lab, you can now automate interactions and measure real responsiveness using Lighthouse user flows. If you cannot invest in user flows, but still need lab automation, then that just works out of the box. Well, then the best way to predict responsiveness from the lab continues to be to just measure total blocking time during load. Actually, we took all the sites in HTTP archive and looked at their lab measured TBT. Then we checked how well that metric predicted the real field metrics, both FID and IMP. In other words, how often do lab and field results agree? We found that IMP is actually twice as correlated with lab measurements, lab measured TBT and FID. While nothing beats actually measuring your field data, this was a nice result for those of us who rely on lab automation. Okay, we talked a lot about the benefits of IMP, but how exactly is it defined? It really may be best to read our full developer documentation at web.dev/IMP, which gives a detailed explanation and links to examples and reference implementations. But at a glance, it comes down to 3 steps. First of all, we have to measure all interactions. Each interaction may have multiple events, and those events may lead to multiple animation frames. So far, each interaction, we simply report the duration of the worst performing part. Each interaction is assigned one single interaction to next paint value. Next, for the whole page lifecycle, we pick one really bad interaction. Although there may be many interactions with the site, each page load reports only that single value for IMP. Now, most sites have relatively few interactions, and for this vast majority, it's fine to measure just the single worst interaction. However, some sites are very interactive, for example, text editors or chats or games. If you measure enough interactions, you will eventually find some hiccups, even on a responsive site that users love. So we end up measuring a high percentile, which basically overlooks a few outliers on such sites. Again, the details are a bit tricky, and it's best to read them in the documentation. Finally, as with our metrics, we assess a site by looking at its 75th percentile scores across all page loads. On today's web, we have found that 200 milliseconds is an ideal threshold for good responsiveness. While at 500 milliseconds, it is reasonable to consider that responsiveness is fairly poor. We mentioned earlier that users expect interactions to be no more than 100 milliseconds. So why is 200 milliseconds the threshold, even at the 75th percentile? Well, a few reasons which come down to achievability. First, remember that we are recording all interactions across the full page lifecycle. Even on the best sites with best devices, even when most interactions are fast and under 100 milliseconds, you will always have a distribution of latencies. We want to see improvements across the board. I think we are at 3 o'clock right now, so I will cut this slide deck a little short because we went through already the main links and the main messages. So this is a very interesting new metric, the IMP. So read that documentation, and I will try to share somewhere these links too. So the IMP demo, the Crocs Web Vitals extension. And but we are at time now to start and hop onto our next stream. I don't want to delay our next presenter. I will look a little bit in the chat. We already see the other stream link there. So please come over there to the other stream. Oh, yes, there's also a survey, which I will share with you in the other stream. Okay.